One day, a time traveler decides it is a good idea to teach the people of the medieval ages about arcs and chords of circles. At last, I, the great Joe Billy Bob, have invented the time machine. I have now traveled back to the Middle Ages to spread enlightenment to these poor, uneducated people.
Ah, a demon! Somebody save mine!
What? I'm no demon. I'm a savior.
Spare a penny?
Oh, none on me, but...
Guards! Guards!
Wait! Stop! Listen to me for a moment.
I shan't listen to thy lies.
No. This is about circles.
Circles?
Well, their shape. An arc is a segment of a circle. It is formed by 2 points in a circle and the distance between them. The center point of the circle is able to form an angle with these 2 points. If the measure of this angle is less than 180 degrees, as you can see here, then it is called a minor arc, this distance here. If the measure of the angle is greater than 180 degrees, as you can see here, it's called a major arc. If the distance is called a semicircle, as you can see here, 180 degrees, 180 degrees. And wow, you're very large.
What is going on here? Why are you talking to this demon? Knight, sir, he's attempting to get me to go against the kingdom.
Such a crime is treason.
He used a lot of words I didn't know, so that must be the meaning.
Mr. Knight, sir, you're a very powerful and merciful person. I hope...
The dungeon with thee, foul demon. Flattery will get thee nowhere.
Wait, you've got it all wrong. Let me talk to your leader.
Okay. Would you prefer to see the Pope, the King, or the cold, blood-stained floor of a prison cell?
Off with his head!
The Pope, please. But before that, would you like to hear a lesson?
Nay, stay your tongue.
Naming arcs is a fairly simple system. For minor arcs, it is always taken to be the endpoints here, such as N, T, because their endpoints are N and T. However, to avoid confusion with naming minor arcs and major arcs, the major arc also has a point on it in its name. So, for this major arc, it would be called NRT, or TRN. Ah ha ha ha, soon I shall rule the world. Your Pope, he's kind of...
Yes?
I mean, he's not exactly...
What art thou trying to saith?
There's something a little... Like he's...
The absolute perfection of the human body, I know. Let's throw ourselves at his feet.
Hearken, knave, what are they doing here?
My lord, he is a demon coming to spread lies.
Wait, you are my royal guardsman. Never mind. What of the human you bring? I am the humble Joe Billy Bob, and I am here to teach about circles. What do you know of circles? They painted my red door black. Hey, didn't the rolling
Oh yes, never mind. The stones that are rolling did that. Wait, those guys aren't alive yet. Be quiet. Tell me about combining arcs. How did you know that was next part of my lesson? Look, a man about to be vaporized by a blaster model ZX-8. Where? Right where you are standing, if you do not tell me about combining arcs.
There are 360 degrees in a circle. To find out the measure of an arc in a circle, you subtract the measure of the rest of the arcs from 360, and the result will be the measure of the arc that you are missing.
Lies!
Okay, imagine two adjacent arcs. Adjacent means right next to each other. Because they are right next to each other, they share a common endpoint. So arcs WT and TF share the common endpoint of T.
Lies!
Will you please stop doing that?
No, you lie.
Formed by the two endpoints they do not share, W and F. The measure of this arc is the measures of WT and TF combined, which would be, in this case, X plus Y.
Lies!
Now, for example, take a clock. Imagine the hands as the segments that connect the points in the circle to the center, as so. Here it is from the 29 minutes to the 46 seconds. This works with all of the second, minute, and hour hands. Since there are 360 degrees in a circle, every minute on this clock is 6 degrees. Therefore, the degree of the minor arc between these hands is 17 times 6, which equals 102, and the degree of, this is the minor arc, and the degree of the major arc is 300 minus 102, which equals 258.
Lies!
Arcs can also be congruent by having the same measure. So if x equaled y, then the arcs would be congruent.
Lies! This is lies.
This is Sparta!
Whoops. I did not mean to do that at all. Ha ha ha, I am amused by this. You have bested my royal guardsmen. You shall now fight in the royal arena for my entertainment. Wait, what? Ladies and gentlemen, this is the Gladiator Arena. Tonight you'll be witnessing a crushing defeat given to a physically incompetent loser by one of the many people stronger than him. Woo! Yes. Beat him up! Yes. Destroy that silly American.
Phew, looks like I have an easy match today. Hello, meat. Are you here to referee the match? No, I'm here to participate.
Uh-oh. Wait a second. If you're that large, and the announcer was referring to something about a physically incompetent loser, then, hey! Let the public humiliation begin!
Please don't kill me. I'll teach you about chords.
Will they make me able to pound you harder? If I say yes, will I have a minute or two more to live than I would otherwise? Why, yes. Then yes.
Chords are segments in a circle, rather than on a circle like arcs are. They're also between two endpoints, and two endpoints will form both an arc and a circle. Chords form a way to prove arcs congruent, and arcs form a way to prove chords congruent. Because if chords are congruent, then their arcs will be 2. If arcs are congruent, then their chords will be 2.
Does this mean I win? The physically incompetent loser anticlimactically bores the actual gladiator to death. Boo! Boo! You are bad! Because of the staleness of the match, another one shall be called right now. This time, the weakling is against the Beast. Yeah! Woohoo! Release the Beast, yes! Release the Beast! Oh no.
A diameter is a chord formed by a semicircle, as shown here, dividing the entire circle into 2 halves. If a diameter is perpendicular to a chord on the circle, which means that it forms 4 90-degree angles with it at the point of intersection, that means that it bisects the chord and its associated arc. Bisects means divides into 2 equal parts. As well as, if a chord is perpendicular to another chord in a circle, that means the first chord is a diameter.
Stupid bears and Americans. Well, looks like everyone's asleep for some reason. Might as well escape. Yes, I shall now go back to my time against the Pope's will. What are you doing, Joe? I thought I gave you gladiator duty. I was just retrieving some papers in order to teach you more about circles. Oh, really? I think you were trying to escape. Not at all. Why would you think that? You are standing next to your time machine, turning on the engine and talking about how you are escaping against my will. Hey, wasn't I going to teach you more about circles?
I spoke before of how arcs can be proven congruent by proving that their chords are congruent, but how can you prove that their chords are congruent in the first place? If 2 chords are congruent, then they will always be equidistant from the center point. In this case, it is C, and their distance is equal, so the 2 chords must be congruent. This works both ways. If 2 chords are congruent, you know they are equidistant from the center point. This only works within the same circle.
Hey, as some scorpion locked in Mortal Kombat said, get over here. The time traveler returned to the present, where he lived for a while until the aliens found a way to follow him. The aliens enslaved all of us, the humans of the present, because they now knew far more about circles than we did. They lived happily ever after at our expense. The end.